Spatial augmented reality techniques create augmented reality experiences by projecting 3D graphics directly onto the user's physical environment. We present a projected spatial augmented reality system that supports separate perspective views for two users in a face-to-face arrangement, or dyad. Virtual 3D objects are rendered so that they appear as if they are hovering in the space between the two users. We envision the system to be useful in a variety of dyadic, collaborative interactions. For example, in a combat-style game, a player can summon a fireball to their raised hand and throw it at the other player. In another game, players can toss a tennis ball back and forth. Both players see the correct view of the action. Our system, which we dub Mano-a-Mano, uses 3 standard video projectors. Each is paired with a V2 Connect for Windows sensor. 2 of the projector camera pairs are mounted so that they face each other, covering the opposite sides of the room. The third covers the space in the middle. This symmetric configuration of Mano-a-Mano allows for multiple simultaneous views by assuming that each user is unaware of graphics projected on the wall behind them or on their own bodies. Instead, those graphics are intended for the other user. For example, an object such as the globe is rendered twice, once for each user. Here we see the desired rendering for the first user and their corresponding view in the room. Here is the second user's rendering and the actual view in the room. An automatic offline calibration procedure places all projectors and depth cameras in the same world coordinate system. Here we see the point cloud of the static geometry of the room collected from the 3 depth cameras. The quality of the registration can be inspected directly by enhancing the edges of the Connect color image and projecting that back into the room. We expect projected edges to line up well with real edges. The dynamic geometry of the user and Connect body tracking is used to create interactive dynamic projection mapping applications. Interactive experiences such as games are easily scripted in Unity 3D. The Unity editor also gives a convenient overview of all sense geometry and virtual objects in the room. It is easy to map a 3D model to appear as if it is in the user's hand or in the middle of the room above the coffee table. Note how the dynamic projection warps the graphics on the other user's body to deliver the correct impression of the virtual object. Here the designer places an interactive globe in the scene, which appears to hover in front of the user. It is rotated by touch. With a simple catch and release mechanism based on Connect body tracking, 2 users can play catch with a tennis ball. Unity's rigid body physics simulator models the collision of the tennis ball against the real objects in the room. In a combat-style game, a player can summon a fireball to their raised hand and throw it at the other player. Both players see the appropriate view of the action. When a player lands a fireball on their opponent, this is detected as a collision of the fireball with one of a number of spheres which approximate the opponent's shape. Damage effects are displayed on the user. These follow the motion of the user through the use of optical flow-based motion estimation in the Connect infrared image. To evaluate our dyadic projected spatial augmented reality system, we conducted 2 user performance experiments. The first focused on whether participants can perceive projected virtual objects at the intended distance and size, rather than simply as a projection on the wall. Participants were shown a virtual cube of one of 3 sizes and at one of 3 distances. They reported the apparent size and distance of the cube. In one condition, the participants could use a physical marker placed in the scene to help judge distance. In the second condition, the participants judged distance without the help of the physical marker. In the second study, a grid of 16 labeled spheres were rendered to appear between the users. Participants determined which of the spheres was indicated by the other user's pointing gestures. This pointing task explores whether the dyad has a rudimentary shared understanding of the layout of virtual objects between them, and thereby a basis for more advanced collaborative interactions. Please see the paper for user study results. ManoAMano is a unique spatial augmented reality system that combines dynamic projection mapping, multiple perspective views, and deviceless interaction to support dyadic interaction with 3D virtual objects. Most importantly, users are able to interact with 3D virtual objects and each other without cumbersome devices that obstruct the best qualities of face-to-face interaction.